Good morning, students. Can you see the screen? Can you hear me? Just checking.
Yes, morning.
All right, beautiful. Okay. So we intend to have a nice, quick session today. A very efficient session. I want us to work through the vectors class activity that we did. All right. It says vectors and variation, but actually just vectors alone on this paper. This was the class activity that we did on vectors. And then I'm going to do some of the Trigs question, the simple trig question, right angle triangle trig question, so-called or Pythagoras theorem trig questions that are sent in the group. All right, that's the plan for today. And so we should be able to complete this session within 2 hours today. Quick and fast, nice and easy. All right, so let's get straight to it. So this first question gives us these points, A, B, and C, relative to an origin O. And they ask us in part A to write the position vector for each of the points, OB, OA, OB, and OC. Remember, this needs no calculation if you know the coordinates. All right, so once you know the coordinates of the points, there's no calculation needed for the position vectors. The position vector will have the same values as the coordinates. Because remember, the position vector is the vector that will take you from the origin to a point. And so it will have the same values as the coordinates. Because the coordinates still is how you get from the origin to a point. So technically, you're doing the same thing. All right, so A is the point -1, 3. B is the point -5, 4. And C is the point 7, P. And if this is the point A, that means that the vector OA will have the same values, -1, 3, no calculation needed. And the OB will have the same values as the point B, -5, 4. And the vector OC, the portion vector of C, will have the same values as the point C, which is 7, P. And that answers the first part, well, these two parts, part A. It answers part A. All right. Sorry, answers part A up here, part 1, 2, and 3. So this is part A. Then we get to part B, which is now asking us for some displacement vectors. So the first displacement vector I want is BA. And remember, once you know the portion vector of the points involved, so the portion vector of B and the portion vector of A, you know both of them. And so we can use O times the last minus O times the first to get this one. All right, so let's do that. All right, so first one I want is the vector. This thing is kind of slowing up. I don't know what happened. The first thing I want is the vector BE. And BE, the displacement vector, is O times the last, which is the OA, minus O times the first, which is the OB. So it's O times the last minus O times the first. That will always give you the displacement vector once you know the position vectors of the points. And so the OA is this one, -1, 3, minus OB, which is this one, -5, 4. We'll do the calculation. So it's -1 minus a -5 for the first value. So this minus actually becomes a plus. So it's like 5 minus 1 is 4. So it becomes a 4. Then we have 3 minus 4. 3 minus 4 is -1. And so the vector BE is that. That's the vector BE. All right. The next part wants the vector AC in terms of P, meaning P must be in the answer. All right. P must be in the answer. So part 2, we're trying now to find the vector AC, which again, because we know the portion vector of the C is this, and we also know the portion vector of the A is that we can use O times the last minus O times the first. That would be then OC minus OA. That's O times the last, C is the last, minus O times the first, where A is the first. And then the OC is this vector here, 7P, minus OA, which is this vector, negative 1, 3. Again, you have to recognize this minus minus becomes a plus. All right, so have to be careful with those negatives. So the final result for this is the 7 minus minus makes plus 1 makes 8. And then P minus 3 are unlike terms. So if they just leave it as P minus 3. And so that is the vector AC. All right, what good so far? What okay?
Yes, sir.
Good. Then part C now is telling us that the modulus of AC is 10. That's the length of the vector AC. This is AC. Question is saying that that vector is 10. And we have to find the values of P that would make it 10. And the key word here is values with a plural, meaning more than 1. All right? So what they're telling us is that the modulus of the vector AC is equal to 10. That is the length of this vector. The length of a vector, the modulus of a vector, is the square root, because remember it comes from Pythagoras' theorem. It becomes the square root of the 8 squared, that's this dimension squared, and the P minus 3 squared. That is what is equal to 10. Now, if I were to explain this a little bit, I'm just doing like a quick sketch right here. So it is as if we are saying that the vector AC, this vector AC, right? Let's just make a little quick sketch. It's like the vector AC is this. Now this 8 means that to go from the tail of the vector to the nose of the vector, you have to go 8 units this way. That's what this 8 stands for. And you have to go P minus 3 units up. That's what it means, you know. Or it could be that the vector slants down. Because remember, you don't know what this is, you know. So it could be that instead of slanting up, all we know is that the x value on the vector is positive, right? So you know that it's either it slant up like this or it slants down like that. But the x value is positive. So if the vector was slanting down like this, if that was the vector AC, and put it under here, then it means then that this would be a 8 going this way, and then this would be your P minus 3 coming down. And don't mind that this the dimensions and this is not to scale, right? I just make it like a sketch to just explain a little bit. This will be P minus 3. And what they're basically telling us is this length is 10. This length is 10. That's what this means. The modulus is 10. Means that this length is 10 right here. This is 10. Or this length is 10. The modulus is 10. So the length of this vector is equal to 10. Or the length of this vector is equal to 10. So in a triangle like this, remember this is a right angle. You know? This is a right angle right here, you know, 90 degrees. Or if it's this one, 90 degrees. It is Pythagoras' theorem that will give us the length of this one. And Pythagoras' theorem says that this side squared plus that side squared is equal to this side squared. Or put another way, this side will be the square root of this side squared plus that side squared. And that's what we use. That's what we're using here. So that's where this would come from, Pythagoras' theorem. All right? And so we're now solving this equation for the P. All right? And the key thing is not to expand this. Now, I can know a Pythagorean triple relating to these numbers, you know. But there's a Pythagorean triple, which is a 6, 8, 10 triangle. A Pythagorean triple, 6, 8, 10. Those will be the sides of your Pythagorean triple triangle. So in other words, if this is 10, the hypotenuse is 10, and this side is 8, then this side must be 6, must equal 6. But it can also be a negative 6. So looking at this, I could know that the P minus 3 is either 6 or negative 6 by knowing the 6, 8, 10 Pythagorean triple. It comes from the 3, 4, 5 Pythagorean triple. That is doubled to 6, 8, 10. Right? So if you know about that triple, you would know that this P minus 3 is either positive 6 or negative 6, just like that. So I always say to the students, the more things you know, the better. So having that knowledge, you could know that this is either plus or minus 6, just like that, by identifying the Pythagorean triple in this expression. But let's say you don't know, you have to work it out. You're trying to basically make P the subject. First thing you have to do is get rid of the square root sign by squaring both sides. Square both sides. And this square would basically cancel away that square root. All right? So what would happen is that if you square both sides, first this under here will become 64. I'm leaving this. I'm not going to expand it. I'm leaving that at P minus 3 because I don't want it to become more complicated. All right? I just need to transpose everything away from this P. And this side become 10 squared when we square both sides. So this is really 100. Then we'll take the 64 and subtract it over here. Become negative 64. And so it becomes P minus 3 equals 100 minus 64. This is the 100, 64. This is the 100. So the P minus 3 will be equal to P minus 3 squared, will be equal to 36. And then now, P minus 3 squared will be equal to 36. And then now you have to square both sides to get rid of this square. And this is where you have to introduce plus or minus. So what would that mean is that the P minus 3 will be equal to plus or minus the square root of 36, which is plus or minus 6. Why is that? Because remember, if you square a positive 6, you're going to get 36. And if you square a negative 6, you're also going to get 36. That's one way to look at it. Could have also transpose this and work it as a difference of 2 squared, but just leave that for now. But you have to remember that when you calculate square root from a situation like this, you have to remember that the result can be plus or minus, all right? Because a negative number squared is positive, just as a positive number squared is positive, all right? And then now to transpose away this 3, you're going to bring it and turn into a plus, and so the P becomes 3 plus or minus 6. So you're getting 2 values. You're going to get P equals the 3 plus 6 is a 9, or P equals the 3 minus 6. 3 minus 6 is a negative 3. So those are your 2 possible values of P. That would make the modulus 10. But good at that so far, but okay?
Yes, sir.
Yes, sir.
All right, good. Now, the next part of the question, part D, introduces a point D, and it gives us a position vector of D. From this position vector, you know that D will be the point 11, 0. All right, it says you have to use a vectors method to prove that A, B, and D are collinear. And to show that 3 points are collinear, you need to show that there are 2 vectors from the 3 points, 2 vectors from the 3 points that are parallel. So one parallel vectors from the 3 points. And because they're getting 2 different vectors that are parallel from 3 points, it means that one of the points must be a common point. And that's how you show that 3 points are collinear, by establishing 2 vectors between the 3 points that are parallel, and there will also be a common point. That's what you need to show. So let's set it up. So we need to find 2 vectors from the 3 points that are parallel. So we're talking about the points of part D. We're talking about the points A, B, and D. These points are supposed to be collinear, right? We're testing for collinearity. We have to show that they are collinear. All right, so looking for 2 vectors with these 3 points. So for example, you cannot use point C in your proof. You can use AC because C is not one of these 3 points. We already have a vector BA that we found. So yes, we can form a vector between the B and A and use it. So we'll have to calculate one. We have one already. That's what these crystals normally are. Either you have one already, or most times you'll have one already, and sometimes you will have both of them. So we already have one vector BA. It is 4, -1. So that's one of the vectors we can use. So the BA is 4, -1. So I no need to form another vector, either the AD or the BD. Any one of them I find will work. And this time I have to calculate, whichever one I use, I have to calculate it. So let's say just for no particular reason, I'm going to use AD. For no particular reason, I'm using AD. So I have to calculate the AD now. I've decided to use AD. Remember, I could have used BD. So it's AD or BD. I could have used the vector BD if I wanted. All right, but I've decided to use AD. All right, same thing I'm going to do with the AD is the same thing I would do with the BD. So I have to calculate it because I don't know it. It is equal to OD minus OA. The OD they gave us is here, the 11, 0, 11, 0, minus the OA. Remember the OA from this vector was -1, 3. That is the OA vector. All right, so I'm going to put it here. Sorry about that. Sorry about that. All right, so I'm going to put it here, -1, 3. I'm going to work out what that vector AD is. So this minus a plus, remember. So it becomes 11 plus 1 is 12. And then the 0 minus 3, that becomes a -3. So this is the vector AD. So I now need to write an expression that these two vectors are parallel. I need to express one as a multiple of the next. And it is obvious that this is the larger one. And if you look at these values, this value, this actually is 3 times this one. In other words, I have to multiply this one by 3 for it to be equal to that. And so the method that we taught in class was to work to get these two sides equal. And when one is smaller than the next one, as this one is smaller, I say multiply the smaller vector to make it become equal to the larger vector so that they can equate. All right, I can look at this and see that this is a 3 times relationship. You know, this big one is equal to 3 times this small one. I can see that, you know, but just to just show the process, what we'd have to do is to get this one equal to that one. I'd have to multiply this one by a 3 because I want this to become equal to that. So I want this 4 to become 12. I would have to multiply it by a 3, for example. When you multiply this vector equation by 3, remember to multiply this side by 3 as well. And so that equation will become 3BA equal, multiply this by 3, it will become 12 -3. And so now, because these two things equal, it means that this and this are equal. And so we can equate as our next step. Equate the vectors to establish that equation that we want. Equate them. So when you equate them, we're going to get that the AD is 3BA. The AD is 3BA, which is what you're trying to get. This equation now, because you have expressed one vector as a multiple of the other vector, it means that these two vectors are parallel. And clearly, there's a common point A on both vectors. A common point A. And so you have gotten what you want to prove collinearity. Prove that 3 points are collinear. Parallel vectors with a common point. And so you have to state those conditions as a part of your proof. First thing is that they are parallel. AD is parallel to BA. Why are they parallel? Because of this equation. Once you're able to express one vector as a multiple of the next, then those two vectors are parallel. And then again, we have a common point A. This is the second thing that must happen for you to have collinear points. So the second thing is that we have a common point A. So A is a common point. And because these two things happen, it means that the 3 points involved, A, B, and D, are collinear. So we can draw the conclusion. So therefore, A, B, and D are collinear, meaning they are on a straight line. 3 points are collinear because we got this equation. That is it. What good at that?
Yes, sir.
All right. Let's go on to the next one now, number 2, which is a popular kind of question that they like to set. They like to set these kind of parallelogram questions in CSEC. So it makes sense for you to get comfortable doing this kind of question. It's almost like they're always asking the same thing. All right. So the question gives us the diagram here, and it gives us some information. As you read, you're going to implant what you know on the diagram as you read it. So it says, the diagram below not drawn to scale. It shows a parallelogram. It's a parallelogram. So if it's a parallelogram, automatically you know that these two sides are equal in length and parallel. And these two sides are equal in length and parallel. And so whatever vector this one is, this vector is the same vector. Whatever vector this one is the same vector. All right, but let's read. It says the point S is on KM. This point S is on this line KM, such that MS is 2SK. And sometimes what I tell students to do is put this information on the lines so you can see what the relationship is. And it's basically trying to get the ratio. How does this point divide the line? Is it a 1 to 2 division? Is it a 2 to 3 division? Is it a 1 to 3 division? Most times it's a 1 to 2 division. Most times. And that's what it is this time. So the question says that the MS is 2 times SK. So one way to do it on the diagram is to actually write what they have said. They said that this MS is 2SK. And this is just a SK by itself. So this is 1 SK. And then if you imagine that the SK is not there, they say that the line is broken down into 2 to 1. So this part of the line has 2 equal parts, and this has 1 of those equal parts. And so the total parts on this line is 3. It therefore means that this side is 2/3 of the entire line. 2 to 3 parts of the MK. The entire line is MK. And this part down here is now 1/3 of the entire line. So it's 1/3 of the MK. All right, so the line is broken down 2/3 and 1/3. All right, by this equation right here, this relationship that they gave us. But let's continue. It says the vector OK is V, and we can see that on the diagram here. This vector OK is V, and the vector OM is U. This vector up here is this U. I'm going to populate the diagram with information. So I can leave the 2 and the 1 here. Or you can just remember that it's a 2 to 1 relationship, right? So since this vector is V, the vector across here is also V, going in the same direction as this one. So I'm going to put that on the diagram. So this vector up here, I'm going to call it V, just like this one. I'm going to underline it. And similarly, since this vector going up here is U, then the vector going up here is also U. So let's put it down there. This is a U. All right. So those are the vectors that we know. Let me take these out. I can remember that this is 2 to 1, right? 2 parts, 1 part. This is 2/3. This is 1/3. All right, of the entire line. All right. So the question is asking us for these vectors now. Oh, I think that this one was first, right? This one was MK. So let me erase this and put them the other way around. So the first part was the vector MK, not this. The second part was SL. And the third part was OS. That's how we set it up in the class. OS, all right? So That is it. So we need to find the vector mk first. So the vector mk is the vector that will take us from here to here. Now remember, vectors at this level is basically how you go around a diagram like this, from point to point, and you have to be traveling along these vector directions that you know. You want to be traveling using those vector directions, distance and direction. In this case, we want to go from M to K. All right. So looking at this diagram, going from M to K, I can start at M and go across to L first using this vector. And then I can come down to K using the negative of that vector, the minus of that vector. Why is it minus? Because I'm going in the opposite direction to the opposite direction to that. And so I can see it as this would be a V, and then coming down this way, that would be a minus U. So it means that the V minus U will take me from M to K. Could have also gone the other direction. Could have also gone the other way and come down here to O first. That would be a minus U again. Why is it minus? Because I will be going in the opposite direction to that U. So going down here will be a negative U. Same distance, parallel, but opposite direction. And introduce a negative for opposite direction in vectors. And then from O, we will go straight across here using this V. And so it will be minus U plus V. So is that a minus U plus V, or if using this direction, it will be then V minus U. Right? But these two really are the same. All right. I'm going to use the V minus U because it is just more aesthetic to look at. Let's put it that way. So I'm going to write that over here. That the vector mk, I use the V to go out to L, and then minus U to go down to K. And that is it. Simple as that. That is vector mk. All right. So now that you know the vector mk, guys, it is basically as if now we know this road now. We now know it. We now know this vector all the way down here is V minus U. So because we now know this vector is V minus U, means that we can travel along this vector now. We can travel along this now using the vector V minus U. So it becomes like a known road now. The vector is like a road, you know, distance and direction. All right. So it means then we can come a part of the road as well to here. I will know that this was 2/3 of the length. So that vector right here will be 2/3 of the mk. And 2/3 of the mk means 2/3 of the V minus U. Or if necessary, we can go from S down to K. And we are keeping the direction this way. But that is the M to K that we have. I don't want to be reversing any direction, because if you go in the opposite direction on a vector, you have to introduce a negative. And we don't want to complicate it. So it's best we traverse along this vector across here, this diagonal, going this way, in the same direction of the vector that we have over here. It's just easier, but you don't have to introduce the negative. Go back to this. This vector here now, down here, will be 1/3 of the mk if you need to use it. And mk is V minus U. So that vector will be 1/3 of the V minus U. All right, so we have to recognize that. All right, so we're going to have to use one of them in the next part of a question, which is for us to find SL. And that is the vector from S to L. All right, and remember, to go from S to L, I can't use this vector because we don't know anything about this line. But remember, we know that down here is 1/3. So to go from S to L on this diagram, I would go from S to L. I can travel along this road, yes, because I have that vector. So I would come down to K first using 1/3 of the mk. And then from the K, I would use the U to reach up to L. So if you look at the diagram, you can say to go from S to L, I can go from S to K first, and then go from K to L. But the S to K is 1/3 of the mk. And you cannot do that because you want to use something that you have found already. That's how these questions usually are set up. What they ask for first is used to find what they're asking you for second. And you're going to add the KL now, still. And so the 1/3 MK really means 1/3 of this. And so it is 1/3 of this part, which is 1/3 V, and 1/3 of this part, which is minus 1/3 U. And you're adding back this KL, where this KL now is equal to U, so you're adding a U. I'm going to write the answer. So this is only V term in it, 1/3 V. So I'm going to write 1/3 V. Then I need to consolidate these two. So it's like a whole U minus a third U. Or put another way, this U is the same as 3/3. Make it have the same diameter as that. Then now, to add those two, what did I do? To add those two, it will be 3 minus 1, which is 2/3. 2/3. It will be 3 minus 1, which is 2 all over 3. All right, look another way again, as I said before. We could view it as a whole U minus a third U. A whole minus a third is 2/3. So any way you want to look at it, that's going to be 2/3 U. So it's plus 2/3 U. All right, so that is SL. And because this is vectors and we have a diagram, it's a good practice that whenever you're doing a vectors question with a diagram and you get an answer like, for example, this one, you want to test your answer on the diagram over here to see if it makes sense, if this vector will actually take you from S to L. All right, you want to do that little check. All right, so let's do it over here. So this is saying to go from S to L, I must go 1/3 of a V. Starting here to get to here, right? That vector, to get to it, it is saying go 1/3 of a V first. So remember now, this is a whole V. I don't want a whole V, I just want 1/3. So 1/3 for divided to 3 equal parts. 1/3 might be around here. That might be 1/3 of a V. So I'm going to copy this up as if I started at L and I did a 1/3 of a V. So that's going to take me to somewhere around here. And then this 2/3 U now means 2/3 this way. So then let me do it now. So this is a whole U. I don't want a whole U, I want 2/3. So I divide into 3 equal parts again. 2/3 will be this. So that is your 2/3 U. I'll copy this across. Then bam. Good enough. Shows that 1/3 V, which is this, plus 2/3 U will indeed take me from S to L. And so I can accept this answer as correct. This answer right here. I can accept it as being correct and put it as my answer. And that's one I think you want to practice doing when you're doing a vectors question. When you get your answers, test them on a diagram, if you have a diagram. Once a diagram is involved in the calculation, you're going to test it. All right, so that answers SL. The next part I want is OS. I want the vector from O to S now. Multiple ways to do it, but I'm going to use the diagram. All right, there are multiple ways to do it. Multiple ways to do it. All right, multiple ways to do it. But I'm going to use the diagram and say, okay, how do I go from O to S? I have to travel along this road. So it's either one of two ways to go from O to S. Either I'm going to come out to the K first and then go backwards to the S, go this way. Which I prefer not to do, because if once I'm going in the opposite direction to this vector that I know, which is coming down this way, then I have to introduce a negative and I might make mistakes. So I have that option, but I don't need to choose that option, right? I can instead come up to M first. And then from M, I go down to S. Which is fine, because then I'll be going in the direction of the vector that I already know. All right. So the vector from O to M up here is this U. And then from M to S is 2/3 of the MK. That's what it is now. So let's set it up. So see here now, going from O to S is the same as going from O to M first, going from O to M first, and then going from M to S. The OM right here is U, plus the MS is 2/3 of the MK. 2/3 of the MK. And the MK is V minus U, remember? So this is U plus, we're doing 2/3 of V minus U now. Remember the MK is V minus U? So we're doing 2/3 of this. So we're going to be 2/3 of this part and 2/3 of that part. And so this thing here becomes 2/3 V, that's a V part, minus 2/3 U, that's a U part. And so consolidating the values now. This is the only V term in it. And so I'm going to write that as 2/3 V. Then that's a whole U minus 2/3 U. A whole minus 2/3 is 1/3. This whole U minus 2/3 U gives me 1/3 U. I'm going to add 1/3 U to that. So that is the vector OS. And again, because of the diagram that I have, I can check if this answer that I got, if it makes sense, if it is true. If that vector, in fact, will take me from O to S, I can check it on the diagram and just kind of sketch it out. So it is saying to go from O to S, I must go 2/3 the V first. So remember, this is a whole V. I don't want the whole V, I want 2/3. Let's break this down to the 3 equal parts, and then this will be 2/3 right here, approximately. So I'm going to just leave that there. But that will be 2/3 V starting from O. So this will be 2/3 V. Then from here now, I need a 1/3 U. So this is a whole U. I don't want a whole U, I want 1/3. I divide it into 3 equal parts again. So 1/3 is about this. So I need to do now is move this across over to this end, and voila. You see that the 2/3 of V that we have and the 1/3 U did in fact take us from O to S. And so we can accept those answers and be comfortable and be confident that they are correct. So that is the answer right there. The calculations and your diagram match. But go to that. That is the
Yes,
answer.
sir.
All right, good. All right, I want us to jump onto some of the Trigs questions now that I gave you. All right, let's jump onto some of the Trigs questions. And just do a couple of them right a day afterwards. Remember, I sent a multiple choice paper to the group, guys. So you all have to go and read that multiple choice paper for me. All right, so let me see which paper I gave you. I don't remember which paper I gave you. Let me see. Let me check something here quick. Let me see quickly. All right. So I gave you about 6 questions. I gave you January 2024. All right, let's find that one. Here it is, January 2024. What question 3 also? All right, what question 3? That's where the simple 3 questions usually come. So it's question 3A, must be 3B, this one. So I think I gave you this one, right? This one right here. I gave you this one. Nobody did I give you this one to do?
I don't know, sir. I don't think so.
You don't think so? Really? Why won't I give it this one? I like to give it a more recent questions first. Maybe too easy. Just one part. Let me see. So calculate the H. Let me see what it says. Diagram below shows an equilateral triangle. So if it's an equilateral triangle, it means that all three sides equal. All right. And the base is 13 centimeters, and the height is 8. And I want us to calculate the height 8. Yeah, man, we can do this one. So if that first, if it's an equilateral triangle, right? There are a number of things that mean in this triangle because that's equilateral. The three sides are equal and the three angles are equal. So this angle here is 60 degrees. This is 60 degrees. And up here 60 degrees. All right. Now, if this is the perpendicular height, then this line divides this angle 30, 30. All right. So this side of it is 30 degrees. And this is 30 degrees. So that's some information you know by virtue of it being equilateral. Additionally, this is 13. And this side is also 13. And this side is also 13. So I have multiple ways to calculate this height. All right. Now we can decide to work, for example, in this triangle, which is a right angle triangle. And let's say we decide that we're going to use this angle as our angle of reference, or the angle under consideration in that blue triangle. Then in that case, we would know this hypotenuse. Let me write it in blue, 13 centimeters. And we would want to find the opposite. And so we could use sine in that right angle triangle that I've drawn in blue. Just pick out that blue triangle and we can work sine. I'm sorry, I'm going to take off this 30 degrees up here. Just to say we're not really using this, right? Just highlighting what we can use in blue. So we could use that 60-degree angle and use sine equals opposite over hypotenuse. Because why? Why are we using sine? Because we might so tower in a right angle triangle. And the one that you use depends on the sides that are involved. So if we're working in this blue triangle, then we would want the opposite. So the opposite is involved. So I'm taking O for opposite. And we know the hypotenuse. The hypotenuse, remember, is the side opposite the 90. So that's the hypotenuse. So taking the H, taking the H. So this one with two ticks is telling you which one you have to use. With practice, you will automatically know which one to use without having to do this, you know, with practice. But you just automatically know what connects to equations. Right? So this one I can use sine to do it. So I can use sine of 60 degrees, sine of 60 degrees equal the opposite side H over the hypotenuse of 13. Then to make H a subject, I could take the 13 and multiply it up here. And so the H will be equal to 13 times the sine of 60 degrees. And it's about putting this in a calculator. Let me get my calculator on the screen here. Let me see if I can find it. I'm going to show you another way that we could have used to do it. Just see there. Just to show you more than one way. And that's what I love about Trigs questions. Trigs questions, you usually have multiple ways to do it. That's the beauty about Trigs. That's what I love about Trigs. That's why Trigs is one of my favorite topics, because the questions, you have multiple ways to do a lot of the questions a lot of the time. So we're doing 13 times the sine. Now notice that this calculator is in radians. So the RAD up at the top there, RAD, I don't want radians. I've changed it to degrees. I'm working in degrees. That's what I told you in the class. Make sure your calculator is in the right measure for angle. So we're doing the sine of 60 degrees now. Put in the 60 there. And so the answer is 11.3. The three significant figures. So the H would be 11.3 centimeters. That's one way to do it. Let's look at another way we could do it. Let's say we didn't implant these angles, right? Let's look at another way we could do it. So another way to do it is to not consider the angle, all right? Let's say we're not considering the angle. Should I erase it? All right, let's say we're not taking the angle. But again, because this is an equilateral triangle, this side is 13. And this perpendicular, this height is going to bisect the base. And so what would happen? Let me draw this part in perp. What would happen? All right, let me do the other method over this triangle then. All right, let me do it over this triangle. So let me undo, leave the 60. I want to do it in purple on the other triangle. So let's say I'm working on other triangle now, and I'm not using the Trigs. I'm going to use Pythagoras' theorem this time. So let's say I'm working on this triangle, because this triangle and this triangle is the same, you know, they're congruent, right? But I'm not going to use the angle this time. This is still 90 degrees. This side is still 13. So this is still 13 centimeters. All right. But then now, because this vertical line here, it divides the base equally. So this side is 13 over 2 or 6.5. Let me put 13 over 2. This side is 13 over 2 centimeters. 13 over 2. 13 over 2. And so we're trying to find the height now in that triangle. I'm going to use Pythagoras' theorem this time in that purple triangle. So we're working in the purple triangle now, right? I'm using Pythagoras' theorem. Pythagoras' theorem says that this side squared plus this side squared is equal to the hypotenuse squared. So I can say 13 over 2 squared plus the h squared that we don't know is equal to 13 squared, the hypotenuse squared. And now we're trying to find the h. Mute your mic. Oh my goodness, who is that? Mute your mic, please. Singer, mute your mic. So to make h a subject, we would transpose this first and get h squared equals 13 squared minus 13 over 2 squared. I could put 6.5 here if you wanted. And then to get rid of the square, we would square this side. So I can actually just take off that and leave it like that. A person who practices a lot will know that the h will just be equal to this without having to write this out. And I'm certain now that if you do this calculation, your h is going to come out to be the same 11.3. Let's look at it on the calculator. And that's the beauty about Trigs. There's always multiple ways to do a question. Multiple ways. I can do it another way where we use sine, we use cos. Instead of sine, we could use cos. We could use a 30 degrees up here and use cos. All right. We could use tan. We could use this side and use tan. All right. Multiple ways to get the same answer. That's the beauty about Trigs. So it's just what you see at the time. And with practice, you'll be able to see all the ways to do it and pick the easier way, the way that you choose to do it. All right. But let's work this out and I'm going to get the same answer. So it becomes the square root of 13 squared minus bracket a fraction 13 over 2. As I said, we could have put 6.5 squared. No, not times 2, squared. Yes, we get the same answer. 11.25. Round it up to 11.3. 11.3 centimeters. So that's 2 ways, and yet there's still maybe 3, 4 other ways you could have done this question. All right, everybody good at that? That's the beauty about
Yes,
Trigs.
sir.
Yes.
Beautiful, beautiful. I think that was it on this paper. All right, let me look again. Which other paper? Which other paper did I give you? Let's try May 20. Let's try May 2014. See if there's any on there. May 2014. That was January. Not 2014, 2024. All right, let's do it this way. I'm not seeing it. It's not here. Not seeing it here, so let's get it back from the main folder. That's so hard to find. What's happening? Find it another way. Let's find it another way. I'm not seeing it. I know it's in this device here somewhere. All right, let's see if there's any on this paper. Because to my mind, I sent one to you last night. Ah, there you go. Sent to this one last night. All right, good. So let's do this one. All right, let's do this one. This was on the June paper that's gone this year, 2024. All right, so this was a question. Trigonometry, right angle triangle trigonometry. Remember, we was focusing on the simple right angle triangle trigonometry, which employs the use of Sokar tower and Pythagoras theorem mainly. Okay, that's what we're focusing on now. Going forward, we want to deal with triangles that are not right angle triangles, in which we'll have to use sine rule, cosine rule. Then we're going to look at some of the application topics. We'll use a right angle triangle, which is angle of elevation and depression. We're also going to look at the application topic for the use of sine rule and cosine rule, which is bearings. And we're also going to look at some 3 dimensions situation in trigonometry. All right, so now we're just focusing on right angle triangles. It says a vertical flagpole, FP, this is a flagpole, FP, stands on horizontal ground. Now, once you hear vertical and horizontal, you know that there's a 90-degree angle there, but the angle between vertical and horizontal is 90. So that's why they have this angle of 90 degrees here. All right. And it's held by 2 ropes, PG and PR. So these are 2 ropes, PG and PR. So just visualize it, you know, in real life. That's a vertical pole, and these are 2 ropes holding it in place. All right. It says, as is shown in the diagram, it says PG is 18. That distance is shown in the diagram. And FR is 9.7. That is shown in the diagram as well. And then this angle is 38 degrees. That also is shown in the diagram. So we're good. Everything that they have set up here is represented on the diagram. So we don't need to come back up here to look for any information. Everything is on the diagram. And that's a good practice to have. You always read the information that they give you and try to put it on the diagram. All right? And if there's anything stated up here that's not on the diagram, you would put it on the diagram so that you just depend on the diagram for your calculation. All right. So this question says you have to calculate the height of the flagpole here, this height. So to calculate the height of the flagpole, we're clearly going to come and work in this triangle, because that's a triangle that presents us with the most information. It gives us this angle and it gives us the hypotenuse. All right. And we are now trying to find the opposite to the angle. So we have the hypotenuse and we have the opposite. We can work in that triangle. I'm going to use sine. Sine is a trig ratio that connects the opposite and the hypotenuse. If you don't remember, just write down the SOHCAHTOA. That's a quick way to remember. Opposite and hypotenuse is connected with the sine trig ratio. So I'm going to use sine to get this one up here. So tell the examiner what we're working in. We're working in triangle PGF. So tell the examiner in triangle PGF. So we're using sine. the sine of 38 degrees is equal to the opposite, which is the FP that I want, over the hypotenuse, which is the 18. Then the 18 and multiplied up here, that leaves the FP as a subject. So FP is equal to 18 times sine of 38 degrees. Therefore, the FP is equal to, remember it has to be in meters, right? I call it the height. We're working in meters. So we work it out in meters. Let me get the calculator. See what we have. Okay. So we're gonna say 18 and the sine of 38. I'm getting 11.08. Three significant figures will be 11.1. 11.1 meters. And generally speaking, when you calculate something, you put it on the diagram. So I'll take this information and put it on the diagram so that it is in front of you on the diagram and you can use it as you need to. This is 11.1 meters, the site. I was putting it on the diagram. And so now I can work in this triangle, I can use Pythagoras theorem because that's a right angle triangle as well. And when you work in a right angle triangle and you know two sides, you can use Pythagoras theorem to find the third side. All right, so that's what we want to do. Next part says find PR, the length of the piece of rope. All right, so let me see that one. PR, the length of the length. Let me see. Find PR, the length of one of the piece of rope that is used to hold the flagpole. At this length, I want. This is the hypotenuse. So using Pythagoras theorem, when I say that the PR is equal to the square root of 11.1 squared plus the 9.7 squared. That's Pythagoras theorem. Remember, without the square, you'd have a square on this. All right, that's Pythagoras theorem because this is the hypotenuse. If I don't put the square, then I put the square root over here. And you want to be able to just write that. All right, so it reduces the number of steps that you have to write. All right, so they cannot penalize if you're not writing all the whole thing. Yeah, that is good enough. So we're going to just write the square root of the 11.1 squared plus 9.7 squared. And the answer is 14.7. Did they tell us how accurate must give the answer? No. No, they didn't. So we're going to give it the three significant figure, which is 14.7 meters. But go to that. Easy stuff. Easy stuff. But okay?
Yes, sir.
All right. So see, I have to master these basic things before we get to the nicer things, you know, the sugary stuff, you know, the sine rule and the cosine rule and the bearings. I have to master these basic stuff first. All right. We're going to deal with this in another topic. All right. You plane and solid geometry. We deal with this stuff like this, or the plane and solid geometry. So leave that for the time being. That is that. So let's look at which next which paper I would have probably given you next. I would have probably given you 2023, June 2023. Let me see. 2023, June. 2023, June. Yeah. Okay. All right. And one number 3 is a simple Trigs question. Number 3 also. There you go. This one right here. All right, let's look at this one again. All right. So this question gives us this diagram. So the diagram below shows a semicircle. A semicircle is basically half of a circle with a diameter AC. So this is the diameter across here. Remember, diameter is 2 times the radius. So the center point will be somewhere around here. So this will be a radius. That will be a radius, right? Something like that. It says B is a point on the circumference. That's a point of the circumference. and AB equals BC is 8.2. So this length and this length is the same. All right. So what is going to happen, guys, is that a diameter will always obtain an angle of 90 degrees at the circumference. So this angle is 90 degrees. That is a circular measures thing, but that angle is 90 degrees. I'm trying to say if you need that information. Yeah, you're gonna need to know that that is 90 degrees. That's the thing about this question. You have to know that this angle is 90 degrees. An angle subtended by a diameter is 90 degrees. And we will learn that in the next topic after Trigs, which is circular theory. Right? But this angle is 90 degrees, but it is subtended by this diameter. Don't worry if you don't understand it yet. Just take it for now that that angle is 90 degrees. Remember that this length and this length is the same enough. So this is an isosceles triangle. Question says we have to state the name of the line AD. AD, sorry, that's this line. So any line that joins 2 points on the circumference is called a chord. That would be a chord. The diameter is a chord as well, enough. It's a special chord. It's the longest chord because it joins 2 points on the circumference, but it also passes through the center. So it's also a chord, just like it's the longest chord. All right, diameter is a special chord. Anyway, so that's the name of that one. Then it says find the radius of a circle. Now remember, the radius is the distance from the center to the circumference. So multiple ways again you can do this question. Multiple ways. To get the radius, we can find this length, the diameter, and take half of it. That's one way to do it. All right. Another way to do it is to assume where the center point is here and do a line like this. This is a radius. This will be a radius. And this will be a radius. All right, if we work on this side, focus on this triangle over here. This should be a radius. And this will be a radius. And so this will be a right angle triangle. And then we could find the radius by using Pythagoras' theorem. We could also use Trigs under this question, because we could say, okay, since this angle here says 90 and this is isosceles, these two angles must add up to 90 as well, and they are equal. And so each of them is 90 degrees divided by 2. So it means that this is 45 degrees, and this is 45 degrees. And then again, we can still go like this and say that this side is a radius, and this side is a radius. And then we could use maybe like cos or sine of the 45. Sine 45 equal opposite the radius that you want over the hypotenuse. Remember now that this is a radius because it goes from the center to the circumference. And the line from the center to the circumference is a radius. That's another way we could do it. Work in this triangle and use sine equals opposite over hypotenuse. Or could use cos, same way. Could use cos equals adjacent over hypotenuse with the same 45. And that works because the sine of 45 and the cos of 45 is the same, right? 0.707. We could also come here instead of using Trigs. We could come and work in this triangle again. And use Pythagoras' theorem in this triangle using those three sides, Pythagoras' theorem. So you see, that's the beauty again, I tell you about Trigs. There are just multiple ways to do a Trigs question most of the time. Multiple ways. So whichever way you use, the answer is going to be same. Let me see if I can do it maybe 2 ways here. Let's do one where we're finding the diameter and then dividing it by 2. Let's do it that way first, all right? So the radius is half the diameter. That's the method we use. Remember that this side is 8.2. This is 90 degrees. So this becomes an hypotenuse. Key thing is to know that this is 90 degrees too. Finish that question. To know that that is 90 degrees. Right? That is like a key. Right? If you didn't know that that was 90 degrees, you could still work it by doing this line down here. I know that this is the center of the circle. All right. This will be 90 degrees for sure. All right. But let's say we're working this triangle now. This is 8.2. I'm working in this triangle. Pythagoras theorem we're using. Let's say we're using Pythagoras theorem and trying to find this side first. All right. And we could find the radius straight off the bottom now. It's recognized that this diameter is 2 times the radius. That's how we could do it. So we could say, okay, using Pythagoras theorem, treating all of this as the hypotenuse, 2 times the radius squared is equal to 8.2 squared, that's this side squared, plus 8.2 squared. And so 2 times the radius will be the square root of 8.2 squared plus 8.2 squared. And so the radius will be half of that, half of this, half of the square root of 8.2 squared plus 8.2 squared. Let's see what we get. The radius R. Let's work it out this way and see what we get. And I'm going to do it another way. Let's do the Trigs method afterwards. So we use one of the trig ratios afterwards and see what we get. Let's do it this way first. I'm going to say half time, no, not that. Half, oh man, 1/2 times the square root of 8.2 squared plus 8.2 squared. I'm getting 5.798. This is called a 5.80. So that's 5.80 centimeters. That's doing it one way. Or let's do it another way. I'll draw this other part in purple. We'll divide this up like this now. So okay. Divide this up like this, make this 90. This is also a radius. And we can now use Pythagoras theorem in this triangle with these 3 sides. So in that case, R squared plus R squared will be equal to 8.2 squared. Right? So we could do it that way. Let's set up that way. So we could say R squared plus R squared is equal to 8.2 squared. This is 2R squared. So 2R squared is equal to 8.2 squared. It's R we're trying to make the subject now. So we'll divide by this 2 and get R squared equals 8.2 squared over 2. And then to get rid of this 2 now, the square now, we want a square root. And so the R will be the square root of 8.2 squared over 2. Let's see what we get if we do it this way. Let's see. Let's see what we get if we do it that way. So I'm going to say it's a square root of a fraction 8.2 squared over 2. See, same answer, 5.798, same answer, 5.80 centimeters. And let's do it one other way, because more maths equals better maths. So let me make this smaller and do it another way. Let me do another way right here. Let's do another way right beside it here. So this time I'm going to work in red. I'm going to work in this triangle that I'm now drawing in red. And I recognize that this side and this side is the same. So this angle and this angle is the same. This is 90 degrees right here. So right here must be 45 degrees. And this is 45 degrees as well up here. All right, but I'm working with the bottom 45 degrees. I'm going to use a Trigs method now. So I'm going to say sine of 45 equals the opposite over the hypotenuse. I'm going to use that method now to find the R. So I'm going to say the sine of 45 degrees using a third method. Sine of 45 degrees. I could have used cos equals adjacent over hypotenuse. So the sine of 45 equals the opposite side of R over the hypotenuse of 8.2. Take 8.2 and multiply it up here. You get the R equals 8.2 times the sine of 45 degrees. Therefore, R equals what? So we're doing this now. 8.2 times the sine of 45. I'm going to get the same answer. 8.2 times the sine of 45. Voila, there you go. 5.798, same way. So you see, that's the beauty of Trigs. That's why Trigs is one of my favorite topics, because you have multiple ways to get the same answer to the same question and get the same answer multiple ways a lot of the times. That's 5.80 centimeters. So I've given you 3 different ways to get the same answer on this question. Beautiful. That was it. I'm going to leave this until we do a topic polygons. All right, let's leave that for the time being. We'll do the topic of polygons. So let's focus on the Trigs now. But all right with that?
Yes, sir.
Yes, sir.
All right, beautiful. That's why Trigs is such a powerful topic, because you have multiple ways to do the question. Every topic is a favorite for a reason, you know? So Trigs is my favorite for that reason. Multiple ways to do the questions. All right, so I showed the 3 method here, and I can do it in other ways still. Still, there are other ways to do it. All right, so that's just 3 ways I've given you. All right, so let's look at January 2023. Let's look at January 2023. Can't find it here. January 2023. All right, let's see. Well, there was none on January 2023 like that. Nah. Let me see something. Let me just check something quick. No, I didn't give you the January 2023. I gave you 2021. I gave you 2021. I gave you 2021. All right, I gave you 2021. Sure, so I was 6. Let's see, 2021. There you go. This one. Nice and easy question. I mean, they set up my example. These are like show mark topics, we can't take them for granted, you know. As easy as they are, don't joke around with them. You practice them and you master them. Right? You practice them until you master them. You don't get them wrong. All right, this one says, the diagram below shows a triangle PQR with angle QPR 60 degrees. So they're giving us this angle here 60 degrees. Remember that these 2 angles must always add up to 90. You know, this and this must always add up to 90. Those 2. So this one down here will be 90 degrees minus 62 degrees. Right? So just remember that. But anyway, we can work with this one up here still. All right. It said this angle is 90, so we're working the right angle triangle, and they give us the hypotenuse. They've given us the hypotenuse. And once you know one angle and the hypotenuse, you can't find anything else. You can't find everything else after that. It says find the size of angle PRQ. That's right here. Really? That's just 90 minus 62. This is equal to 90 degrees minus 62 degrees. Well, these 2 angles are complementary angles. Complementary angles are angles that add up to 90 degrees. And those 2 angles will always add up to 90 degrees. All right. So it's 90 minus 62. That's 28. Yeah, that's 28 minus 30 first and then 2. So that's 28 degrees. 28 degrees. Let me just put down the diagram. Right. So this is 28 degrees. But good so far.
Yes, sir.
Good. And then now the next thing I want is the length of RQ. RQ. That's this side I want next. No, your choice. Can I use the 60 to get it and use it as the opposite if you're using the 60? Or if you're using the 28, then this is the adjacent. And using cos. Let's say we're using the original thing that was given. Let's say we're using the 60 degrees. So this is the opposite to the 60. is opposite to the 62 degrees, all right? So we're using sine. Sine equals opposite over hypotenuse. So if we use the 62 degrees, then this is going to be the opposite that we want, and that's the hypotenuse. So I've used sine. All right. So you see another question, you can do it multiple ways. You can use sine with the 62 or cos with the 28. All right, whichever way, your choice. So let's say we're using sine. So is that we're using the sine of 62 degrees equal the opposite side that we want, which is the RQ over the hypotenuse, which is 11. And take the 11 and multiply it up here. And so the RQ will be 11 times the sine of 62 degrees. Or if you're using the 28, it will be the cos of 28 equal adjacent RQ over the hypotenuse still. And then the RQ will be that. So the RQ would be 11 cos 28 degrees. And that is why we say, the sine of an angle is equal to the cosine of the complementary angle, because the 62 and the 28 are complementary angle. So the sine of this one is equal to the cos of this one. All right, and that's why you gotta get the same answer whichever one you use, because that is where the difference is in these calculations. So whichever one you use, you're gonna do the same thing for the RQ. All right, let's go for the calculator. 11 sine 62 or 11 cos 28. Let's look at it over here. So it's 11 sine of 62, which is 9.71 centimeters. It's centimeters, right? Let's make sure. Yes, centimeters. Or we could have used 11 cos 28. The same answer exactly. All right, so that is it. And I think that finishes that question. Easy, easy stuff. Easy, easy stuff. But okay with that? Easy question. Look here, guys. Don't bother going to the exam and get them things wrong, you know. It don't make no sense. Them too easy. You won't bother going to the exam and get them wrong. All right? And put adjacent to the 28 degrees here. This is the adjacent to the 28 degrees. All right, so it's opposite to the 62, but it's adjacent to the 28. All right, but all right to that?
Yes, sir.
Good. All right, which one I gave you next? I think I gave you one from 2020. I gave you one from 2019. All right, so 2020 next. I gave you only 6 questions. All right, and I gave you a multiple choice paper. All right, let's go to 2021. 2020, January. Not finding it this way. There you go. Okay. There you go. Number 6 or something. 5, 6. All right, I give you this one, I think. All right. Look the right angle triangle, but I think I gave it still. Yep. So the diagram below not drawn to scale shows triangle M and P. Okay, these two angles equal. So it means that it's an isosceles triangle. So the side opposite this side, those two angles equal and opposite. So those two are also equal. So this length is the same over here. All right, so this over here is also 11.5. No, not 11, 12. This is 12.5, so that is 12.5. All right. It says, still the type of triangle that it is. It's an isosceles triangle. Isosceles. This is something I want to do as a topic, you know. Types of triangle and so on. But it's an isosceles triangle. Then it says, calculate the value of that angle at n right here. There's 180 minus the sum of these two. So this angle here is 180 minus the sum of these two. So this is equal to 180 degrees minus 2 times 52. There are two of them. 52 and 52. So what is that? That's 104. So 176. Everybody got it? Nobody?
Repeat, sir.
76 degrees. Everybody good at that?
Yes, sir.
All right, so this angle is 76 degrees. Let's put on the diagram. 76 degrees. All right, by this calculation. But the total angle in there is 180. Easy question now. Calculate area of the triangle. So to calculate area of the triangle, I'm going to use a trig form. I think that's why I gave it to you. The trig form for the area of a triangle is when you know two sides and the angle between, the formula comes half AB sine theta. I'm going to draw it for you and show you. So what we're going to be using is that when you know two sides of a triangle, I'm going to be using this identity or this formula. If this is A and this is B and this is theta between them, then the area becomes half AB sine of the angle between them. All right, that's the formula we're using. Let me see if it's on the formula sheet on this. If the formula sheet is there. Let's see. Let's see the formula sheet is there. See the formula here, so this is it. That's the one we're talking about. Half AB sine C. So this formula is focused on this triangle. Half AB sine C. It's focused on this triangle here. I'm marking out in blue. So this is side A, this is side B. Inside is angle C. So that formula is talking about that. All right, we know two sides and an angle between. Half the product on the two sides and the sine of the angle between. So that's on the formula sheet. All right, let's go to just note in your head. I'm gonna study, prepare for exam by studying formula sheet. Don't make sense. Looking for formula and formula sheet takes time. All right, you have it in your head, you don't want to waste that time. So it means then in this triangle, the angle is 76 and the two sides are 12.5 and 12.5. So this area becomes equal to half 12.5 as the A, times 12.5 as the B, and the sine of the angle between them, 76 degrees. That's what it is. Put this in the calculator and work it out. And we are good to go. All right, let's do it to the calculator. All right, so the half is 0.5 times 12.5, 12.5. And 12.5 times 12.5 is 12.5 squared times the sine of 76 degrees. That is 75.8 centimeters squared is the area of that triangle. And it's done. Easy, 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 easy. But all right with that,
Yes, sir.
Good. Easy question. I think there was one on 2019 that I gave you. Just about coming to the end. Timing not so bad today. 2019. So I want to go and do multiple choice paper that I sent you. And remember, you have to work on the revision paper that I sent in the group that I gave in class. I think I'm going to send it in the group as well. I'm going to send it in the group as well. To 19, this is pretty much. Not seeing it there. Let's find it another way. One last look. All right, let's find another way. Not there. Let's go further down. Must be further down, down. I'm not seeing it. Didn't I give you one on this paper to do? Really? Sure, I gave you one on 2019. I didn't give you one on 2019 to do. I didn't. Let me look back in the group. Hold on a second. Oh, January 2019 I gave you. Sorry, my mistake. It's January 2019. January 2019, not the June. January 2019. Sorry. We're looking at the wrong paper. This one I gave you. Good. Yes, I think this is the last one I gave you. Last one I'm going to do, all right, for today. All right, so this one basically centered on the proof of some identities that students to know at mass level. Once again, you need to know it at the mass level, but it shows a connection between the trig ratios and Pythagoras' theorem to arrive at some trig identities that are commonly used, commonly known and used. And this question is basically asking to prove them. All right, I'll have to do this follow instruction and it work itself out. It's a diagram below shows a right angle triangle with sides A, B, and C units. All right, this is the hypotenuse. And we have these two other sides. All right, it says using the diagram, express C in terms of A and B. That's Pythagoras' theorem you want to know. The formula connecting three sides in a triangle, or the theorem connecting three sides in a right angle triangle is Pythagoras' theorem. And so it is that C squared is equal to A squared plus B squared. Because it said C, express C as the subject. You want to make just C the subject. So I'm going to get rid of the square and write C equal to square root of A squared plus B squared. So this is what I would give for my answer rather than this, because it said C. I think this is what they're looking for. This is true enough, but this is not C, that is C squared. It says express C in terms of A and B. This is C in terms of the A and the B. All right, that is that. Next part says now, write in terms of A, B, and C expression for sine theta plus cos theta. Let's look at the diagram. So based on the diagram, this is the hypotenuse, remember? So this angle, this becomes the opposite. This is the adjacent. And then here is the hypotenuse. Let's just write them up here. The sine of theta equal the opposite A over the hypotenuse C. And the cos of theta equals the adjacent B over the hypotenuse C. So these are the two we have, and I want us to add them. Place this here. All right, so from these, using purple, from these, we can go and add these two. And so the sine theta plus the cos theta becomes equal to A over C plus B over C. And since these two diameters are the same, we can write this as A plus B all over C. That is sine theta plus cos theta equals that A plus B all over C. What are we going to do that? Nice and easy. But okay?
Yes, sir.
Good. Then the next part now says, using the results from A1, A and B in part 1, show that this is true. Show that sine squared, show that sine theta squared plus cos theta squared is equal to 1. All right? So let's remind us of what we have. We have the sine theta equal A over C, which therefore means if we square this, it means then that the sine theta squared is equal to A squared over C squared. And the cos theta is equal to B over C, which means that the cos theta squared is equal to B squared over C squared. So here's the adding them. So we're adding these two things. And put this part in red. Things that we need to add. All of this. Change that to a different color. Come again. All right. So we're going to add these two equations now. We're trying to form this side. So we can come back down here and say, therefore, sine theta squared plus cos theta squared is initially equal to this plus this. Adding them. So we add these two things. Because they have the same denominator, it really becomes the sum of the numerator over the common denominator. So it becomes A squared plus B squared over C squared. But then the A plus B squared is C squared enough. Come up here. I'll put another way. This C squared is A plus B squared. C squared is A plus B squared. So we can do it that way. Replace this C squared with A plus B squared. So this all becomes equal to, let me shift this over a bit. I'm going to make it smaller. So either way you can do this. You can either write this up here as a C squared or write this under here as a A squared plus B squared. It doesn't matter. Let me write to change the C. So it's A squared plus B squared over the C squared is the same as A squared plus B squared. So you divide something by itself, it becomes 1. And so you'll see that the sine theta squared plus the cos theta squared is indeed equal to 1. Another way to write these two is like this. Sine squared theta plus cos squared theta equals 1. So this is just another way of expressing that. This is actually the standard way to express it, this one. But that is the answer, right? That is the proof. This was shown. shown to be true. That sine theta squared plus cos theta squared is equal to 1. Remember, right here, we could have also changed this to c. So we can say or, let me put it here so in bracket. So for this one, we could say or we could put c squared over c squared. All right, we could put this instead. So instead of a squared plus b squared over a squared plus b squared, we could have changed this one and put it as c squared. So c squared over c squared is still equal to this 1. And we look at it, you're going to get 1 right there. That is it, guys. That's it for today. I'm going to end it there for today. Very good?
Yes, sir.
All right. So
Yes, sir.
remember, continue working on the paper. We're going into revision mode now. All right. We're not going to do anything new, no new topic. Just revise all that we have done since September. So do the worksheet that I sent you in the group, that I gave you. I'm going to send it in the group as well. In fact, I think I'm going to do it now, right after this class. I will also share the video of this class. So those persons who are not in attendance can watch the video. And you who are in attendance can go back through, look back at some of the explanation, redo the questions that they got wrong or did not do yet. More maths equals better maths. All right, bye everybody. See you in class tomorrow and Monday. All right, bye-bye.